Folks, it's time to turn towards some of the Metronome videos. I told you that they were coming up, and here they are. And what we want to take a look at are the Metronome videos that focus around the suppressor unit. So here's the website all over again, and now we're working in this MSM link. This is the module suppressor unit that Metronome puts onto their instrument, and that's what they call it instead of a suppressor. They just call it an MSM, which is the same exact thing. What you're seeing on your screen right now is the suppressor, and you can kind of see that here, chamber 1, chamber 2, chamber 3, and it looks like there's entry and outlet ports to each one of them, and they're kind of marked. It looks like these two holes here go to chamber 1, and those two go to chamber 2, and these two go to chamber 3. So again, LUN in, LUN out, sulfuric acid in, sulfuric acid out, and DI water in and DI water out. What we've said before in the past is that this sulfuric acid and the DI water have to come from bottles that sit up on top of the instrument, and those liquids have to be pumped in, and they are not pumped by the high pressure pump. What they're pumped by is this rotor unit that you're seeing on your screen right here in the center. This is something that we call the peristaltic pump. Peristaltic pump, P-E-R-I, staltic pump. This peristaltic pump, its only purpose is to turn, and there's a piece of tubing that sits up underneath this clip, and one tubing goes to the DI water bottle, and one tubing goes to the sulfuric acid. As this turns, this creates the sucking motion that's needed, or the sucking action that's needed, to pump that acid and the water through the suppressor unit. So you're not seeing it right now, but up underneath this clip, you would see some tubing that would be dangling over here to the right-hand side, and that would eventually lead to the suppressor unit. And you would also see some of the tubing on the left-hand side that would kind of curl up a little bit, and that goes pointed toward the top where those jugs are going to be located. The peristaltic tubing sometimes has to be changed, and that's what you're going to see in this video. So if I enlarge this up for you, here you do see the tubing over here to the right and over here to the left, and this tubing can collapse over a course of time. So as you begin to use it, as pressure is pushed down onto that tubing and onto that pump rotor, it's going to collapse over time. It's going to get kind of nasty. It's going to start to crumble. It's going to start to dry rot in a way. And this tubing has to be replaced because of that. All right, so if I push play on the video, you're going to see this technician basically unscrew the hook that goes into the suppressor. And then here are the clips. They're just loosened up, and that tubing is taken off. Here's a new piece of tubing. It comes all together for you. Most of the time they're pre-cut and pre-measured. And you've got this header feed that goes over. And then there's this inner insert that gets slid on. And then that gets connected to basically this screw. And as you can see the thread over here to the side, that thread's purpose is to hold the tubing in place. But notice this empty area right up there. That was the purpose of that inner piece. So that inner piece is going to slide over that tubing, and then there's going to be a screw that's basically on top of that. You just tighten that up. And what happens is that that will allow this inner piece to grab a hold of that tubing and just push it up against the head and through the thread. So that way it tightens it up a little bit more for you. The same thing really happens here on the other side. You're going to see the clip or the thread being pushed into the end of the tubing. And the purpose of those screws at the end is just to attach the pieces of tubing together. You know, this is going to eventually go to the suppressor, and that has to be changed. So now you've got this screw basically that you can tighten up without a problem. Now the clip goes back on, the piece of tubing goes back underneath, and then you can go through and tighten everything back up. So here you're seeing them screw those two pieces of the tubing together, and you're going to see them screw these two pieces of the tubing together, and because of that, everything is now connected once more. All right, so that's why that is made that certain way right? So you've got to unhook it from the suppressor. You've got to unhook it from the main lines that feed from those jugs that sit up at the top. And that way this piece can be removed, replaced, and put back on. Otherwise, you would have had to replace the whole piece of tubing altogether. And nobody wants to do that, right? Okay, so now that the tubing is back on, you want to tighten all of that up again, right? So this white clip basically sits down on top of this tubing, and this turns, and that applies the pressure. Well, what you're going to see here is that this analyst or this technician is going to come through, and they're going to tighten that top clip, and that puts a little bit more pressure, and that makes sure that that solution is sucking through the instrument. Here at the end, they're just double checking it to make sure that it is doing what it's supposed to do. Here they've probably have it disconnected. That's fed into like a graduated cylinder or a beaker, and they're just wanting to make sure that it is sucking the solution, acid, water, whatever it might be, through the tubing line before they connect it back up to the suppressor and pretend like it's using and it's not getting used. Here's my trick though. A lot of people will go through and they will double check it that way, and I do. If I am going through and if I'm replacing the tubing, you always want to check it to make sure that it is carrying a flow to it. So normally in this peristaltic pump and this rotor, there's a piece of tubing that dangles to the left and to the right, and that goes up to the bottles up here at the top. And this will eventually go into the suppressor. But here at the very end, if you just kind of put a beaker there and just turn this thing on, what you would eventually see, hopefully, is a drip, drip, drip that happens into that container. That drip, of course, is something very good because that means that you have connected it the proper way and that there's enough pressure down onto the tubing that's causing some flow. If you don't really see any flow that comes out of the tubings here that you've connected to, then that means that maybe this clip is not on there the proper way. It might need to be tightened just a little bit more, or maybe this tubing has completely collapsed on you and maybe you need to put a new piece of tubing there for that purpose. Once this tubing gets replaced though, there's a trick that I do that they're not showing you in the video. And you've got two bottles up here at the very top of the instrument, and one of course again holds sulfuric acid and one is DI. What I like to do is that I like to fill these up, right? So here I've filled this one up and I've filled this one up. And I'll take a piece of tape, like a piece of masking tape or something, and I'll just kind of mark the area on the outside of the jug with the masking tape, and I'll put a line there that tells me where I've filled that jug up to. And then I turn the instrument on and I let it run some samples, and if I see this liquid level slowly get lower, 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 then that means that this is sucking up acid and it is sucking up water. If I see that this is a very slow drain, then that probably means that that piece of tubing is going to cause me some problems and I need to do something about it to fix it. So I might need to replace it after that point. So that's what you're seeing here again. They're tightening that up, and that tightening motion is basically clamping down onto that tubing and allow some flow to happen if you are not seeing that flow coming from the end of the tube. These lines will also have inline filters, and this is something that you've seen before in the other videos, but there are inline filters that are present here. So here's kind of the tubing that you might see here at the very end of this. That is where that filter is going to be. It looks very similar to the other inline filters that you saw in the other videos before. They're going to unscrew these two pieces apart from each other, and there's going to be a small membrane filter on the inside of here. And that membrane filter needs to be removed. Normally, a pair of tweezers will help you out there. And then in this bag here in the back, you're going to see these small filters that are ready to go. So they're just going to grab one of these membrane filters, and they're just going to replace the old one with it. And then they'll screw the two pieces back together to each other, and then away you go. So over course of time, depending on your samples and what's pumping through, acid and water is no different. These filters are going to get crudded up, and these filters need to be replaced on a routine maintenance, and you'll know when it's time to do it. It's better to change these too early than too late. Once they're too late, you begin to have problems, and these could be serious problems on the inside of your instrument. So you might as well change them on a regular basis. It's kind of like the air filters in your house, right? You don't want to wait until the last minute to change them. You want a routine maintenance schedule. And if that includes changing those air filters every month, then that's what you should be doing. And the same thing's going to happen here with the instrument. These things are dirt cheap, people. So you might as well take the extra few minutes and then every couple of months maybe go through and change all of your filters and check all of your tubing to make sure everything is working the proper way. Notice they're using a couple of wrenches here to tighten this up. That's helped to prevent leaks. You don't want that joint to leak. If you do get a leak there, then that means it's not getting to your suppressor. So you might have flow, but it's not making it to where it needs to go. As far as cleaning the MSM, the suppressor unit itself, right? Here's a closer look at the suppressor unit. Notice it's dripping, so that's probably some contamination problem right there. And we need to fix it. We need to make sure that this thing is completely sealed and that all the gunk is gone. So you're seeing them unscrew the suppressor on the front, and the lid comes off. And right here is our suppressor. That's the actual suppressor unit right there. So this hole in the bottom just kind of helps you slide out that suppressor unit. That's what you're seeing there. And that suppressor unit can then be changed. They're going to go in here to the valve because there is a valve back in here that turns. So you just want to make sure all of that's clean too, that there's no gunk back up in there. This is a casing that will hold your suppressor. Some of these haven't, some of them don't. But that casing goes in a proper way. Notice the notches and the grooves. And then this tubing needs to fit into those notches and to those grooves on the back side. So they're going to put the suppressor in, maybe it's a new one, and they turn it around until it kind of snaps into place. And that's how they know that it's kind of properly inserted into the spot that it needs to go into. All right. So now what you're going to see is that this new suppressor piece is now in, and the lid needs to go back on. Notice the notches here. It goes back on a certain way. You just can't put it on any way you want to. So that has to kind of seat down into position, and then hold your finger there, and then take this cap and basically screw the cap and the holder back on into position. Don't let this thing shift around once you start screwing the cap on, because it will not seat itself and you will begin to have leaks at the front end, and you don't want that to happen either, right? Again, leaks are bad. We're plumbers here in chromatography, and if you see that kind of problem happen, we're going to have to fix it. The Docino regeneration, we're not really going to talk about. These are for units that have these Docinos on them, and these are kind of specialized units in a way that we just don't worry with too much. So I'm not going to go into that at all. But we did talk about regeneration of the suppressor unit. You know, how do we clean this sucker out if we begin to have problems with it? So here what you're seeing is that they're going to unscrew this inline filter, and they're going to disconnect the pump from the flow line. So they're going to kind of cap this off a little bit. And what they're going to do is they're going to do a trick, and I'll show you what that trick is in just a second. This one goes to the suppressor unit. You can kind of see that tubing going up in here where the suppressor's at, right up here at the top of your screen. And they have connected the suppressor unit directly to the flow pump line, right? Did you see that? If not, rewind the video and go back and take a look at it. So they're going to take the eluent off. This would be my bicarbonate-carbonate mix maybe, and I'm not going to load my bicarbonate-carbonate mix up. There's actually a better way to clean the suppressor, and a little bit quicker, and you're watching that happen in front of you right now. So instead of the eluent, we're going to put this regenerate solution on. Remember, and this could be one of those recipes that I told you about in a previous video or two ago. And this regenerate solution is going to be pumped through the pump. But the way that they've connected it, they have now taken that pump and they have connected it straight to the suppressor unit. So that's why they did that, because not only do they have the DI bottle and the sulfuric acid bottle going through the suppressor to rinse and clean, but now they can utilize this major pump as the major pump to pump this eluent through directly into the suppressor unit. So there's the regeneration of the suppressor. It happens a little bit quicker that way. You don't have to, but it does force that cleaning to happen a little bit quicker than if you had to just sit and wait and wait and wait and wait and wait for that suppressor to turn all three channels. You're hitting all three channels at once in that case, and that's what you would do. All right? Okay, so our next set of videos that are coming up will be our last set. And if you look over here to the left-hand side of the screen, we're kind of going in order a little bit. And it looks like the next piece is hitting our detectors. And that's exactly what we're going to be talking about in the next video. So the types of detectors that can be put onto the IC systems. Of course, conductivity is going to be the most common, and that's the one that we're going to focus on first. But there's some other choices out there as well, and we want to at least touch base on those and talk about those a little bit. So I think that we are almost at the end of our discussion. We've got a few more videos left. Don't give out on me. And then after that, our field of ion chromatography is going to be pretty much wrapped up. So we've talked a little bit about the theory. We've talked a little bit about the history. We've talked about pieces and parts and why things work and the whole theory that goes behind the separation process and the suppressor, why it's needed. And now we're getting ready to talk about the detection.